Okay, so today we are going to cover section 3 and its linear functions. This will probably be a pretty easy section. You've probably seen linear functions multiple times. So let's go ahead and look at the different forms for linear equations. The first one is called slope-intercept. Many people just say it's y equals mx plus b, where in your equation here, or in the form, the m represents the slope, the b represents your y-intercept. So an example of an equation in slope-intercept form could be y equals 3x plus 4, where there's a number in front of x and then you have a b. Now you may even have some where it's just 2x and your b would be 0. Your y-intercept, it would hit the y-axis at 0. You can also have a negative slope or a negative b. So that is the most common form that you'll see, and it's the easiest form to work with, or one of them. The next form is called point slope, and the y1, the m, and the x, these are going to be the numbers that will change, or the variables that are going to change. The x and the y are going to stay as a variable. So for example, you might be given an ordered pair. So let's say we're given the ordered pair 1, 5, and then a slope of, say, 2/3. And they may say, put this ordered pair and this slope and write an equation in point slope form. In the ordered pair, this is going to be what gets replaced for the x1, y1. The slope, again, is the letter m. So I'm going to take out the y1, the slope, and the x1. Again, the letters x and y will stay as variables. So if it says just write it in point slope, we put in the y1, we put in the slope, and we put in the x1. And we're done. Just be careful if your ordered pair has a negative number. Know the negative would turn it to a plus sign. So for example, if you had the ordered pair -2, 3, with a slope, say, of, we could even say it's a whole number. Let's just say it's 4. So here, I would replace the y1 with 3, the slope with 4, and the x1 with -2. Notice this negative is going to turn this into an x plus 2. So if it says point slope, you leave it just like that. You could also distribute the 4 and move the 3 over and convert it to slope-intercept form. But if it says point slope, all you do is replace the 3 numbers, and that's it. The next form of the equation is called standard form. And standard form is where the x and the y are on one side and then the constant on the other. A, B, and C are just numbers. Now, what's special about the standard form is standard form can have no fractions, and the A term has to be positive. So if you're converting from, say, slope-intercept form to standard form, and let's say your slope was a fraction, you would just have to multiply all the terms by the common denominator to clear it. So an example of a standard form equation could be 2x plus 3y equals 4. Your y could be negative. So we could also have 2x minus 3y equals 4. So just as long as the A term is positive and there's no fractions, this is standard form. Now, later on in the presentation, we're going to learn how to find intercepts. When you're finding the intercept, it's easiest to work with the equation when it's in standard form. And that's how all the examples we're going to be doing is the equations will be given in standard form. Okay, let's learn how to graph now from these different forms. So the first example here is an equation that's in standard form. Again, remember f of x is just a fancy way of saying y equals. So I could just take out the f of x and put y if I wanted to, if you want to see slope-intercept. So when I graph using slope-intercept form, my first point when I graph is going to start on the y-intercept or on the y-axis at the 6. From that point, I will move my slope. Remember that slope is defined as rise over run. So when it's a negative slope, we can graph it two ways. We can either say this -2 could be represented as -2 over 1, or we could say it's positive 2 over 1. Now, if you need to think of slope that way, know that the -2 could mean that you move downward, and then the positive 1 means you would move to the right, or you could say that you're going to move up, but the -1 means move left. So you can move either way when it's negative. You can go up and left or down and right. I know this movement, when I give two options to my Algebra 1 class, it confuses them. So I always tell them, always move right. And then if it's positive, you're up. If it's negative, you're down. But if you're, understand that when it's a negative slope, the line goes down. So you do have the option. You can go up and left or down and right. So for this one, I'm going to plot my first point. Notice I'm at the very tippy top of the graph when I graph my y-intercept of 6. So going up 2 is going to take me off the graph. So I'm actually going to go down 2 and to the right 1. So if I go down 2 and to the right 1, that will give me my next point that I can graph to create my line. Remember that when you graph a line, all you need technically are 2 points. If you want to keep repeating this process of down 2 over 1, you can do that and get a more precise line. So if I wanted to put another point on here, I could go down 2 and over 1, and I can keep doing it. But all I need are 2 points to create a line. A horizontal line. So whenever your equation is y equals a number, this tells me that all of my values of y are going to be -3. So whenever you see it's y equals a number, our graph of the line is going to be horizontal, because every single point is going to be here on -3. So when it's y equals a number, whatever that number is, it's a horizontal line through the y-axis at that number. So it's y equals -3. It's a horizontal line through -3. When it's x equals a number, this is going to produce a vertical line. So for this one, x equals -3. This is going to be a vertical line through the x-axis at that number. So it's just going to be a vertical line through -3. Now, another way that you can graph, let's say they don't give you an equation, but let's say they just give you a random order pair and the slope. Realize that you can graph a line if you know that point and just move the slope from that point. So for example, I can graph this order pair, -1, +5, and then from that point, move my rise and run. Again, it's a negative slope, so you can either go down 5 into the right 3 or up 5 into the left 3. Because again, my point is way up near the top, I'm not going to go up 5, it's going to take me off. So I'm going to actually use this movement, down 5 into the right 3. And that will give me a point right here on the axis. And I can connect my dots, my points, and graph my line. So this would be a graphing technique when it's given to you as an order pair and the slope. Now, if it says write an equation, you could put it into point slope and then graph it that way also. So we're going to find intercepts. And the first way is from a graph. So if I look at a graph and I ask you to find the x and the y intercepts, all I'm asking you to find is where does it cross that specific axis. So let's do the green line first. So for the green line, when I ask you to find the y-intercept, all I'm asking you to find is where does it cross the y-axis. And we can see that it crosses or hits the y-axis at the number 4. So when you write, though, your answer as an intercept, I want it written as an ordered pair. So this y-intercept for the green line is going to be the ordered pair 0, 4. For the x-intercept for the green line, we're going to see where it hits the x-axis. And we can see that it hits it over here. And that ordered pair is -3, 0. Let's try the pink line. Where does it hit the x-axis? What is my x-intercept? It hits it at 2, 0. And then my y-intercept will be 0, 1. Everybody with me on finding intercepts when it's already graphed for you? Now, notice my y-intercepts. Notice my ordered pairs. Look at my x value in my ordered pair. What is it? In my y-intercepts. What's the x's? 0. So this is how we're going to find intercepts when you're given an equation. We're going to set x equal to 0 and solve for y. And then when we want to find the x-intercept, we make y equal 0. So let's try these. So when you're finding intercepts and you're given an equation this time, we're going to set y equal to 0 to get the x-intercept. And when we want to find the x-intercept or the y-intercept, we make x equal 0. So let's go ahead, take our equation. I'm going to first set y equal to 0. Or I'll do the x-intercept. I'll find the y first. So I'm going to make x equal 0. So 4 times 0 minus 5 times y. I have to do it one at a time. So then I get 0 minus 5y equals 0, which is just -5y equals 0. Divide, and y equals, when there's a 0 in the numerator, 0 divided by a number is 0. Now, notice, technically I should be trying y equals 0 and plugging it in, but notice what I just got. So for this particular problem, my x and y intercept is going to be the same. It's at the origin. So just to give you an idea of what you can do to graph this, normally you would find both intercepts, plot the points, and connect them to make a line. However, I can take my equation and put it in slope-intercept form, y equals mx plus b. And notice when I do this, I get y equals positive 4 over 5x. Notice there's no b, because our b was 0, right? Our y-intercept was 0, and so's our x. So in this case, our x and our y-intercept are both at 0, 0. And then from there, I can rise 4 and run 5. And I can put a point. And then I can connect them and graph my line. I missed it a little bit, but it should be going through the origin. Now, let's do it now where we have to get two separate intercepts. So when you are finding the intercepts, if the x and the y-intercept are the same, then you need to find the slope so you can get another point. But when the x and the y-intercepts are different, then you can just plot them and graph the line. Let me show you with example 2. So with example 2, I'm going to do the top of the page or the top problem. I'm going to make x equals 0 for this one to get the y-intercept. And to get the x-intercept, I'm going to make y equals 0. So let's do the top problem. So 3 times 0 minus 2y equals negative 8. Negative 2y equals negative 8. Divide by negative 2. And y equals 4. So 0, 4, and that's going to be our y-intercept. Then for the second part, 3x minus 2 times 0 equals negative 8. 3x equals negative 8. Divide by 3. X equals negative 8/3. So again, we're writing it as an ordered pair, and that's our x-intercept. Now, if it said to graph the line using intercepts, I'm going to take this point and graph them, and then get out a straight edge like a ruler, or you could use your ID to connect the points. So let's go ahead and try and graph this line. I would go ahead and make my axis here. And my first point is going to be the y-intercept, and I could go 1, 2, 3, 4. I'll graph that one. Now, notice this is an improper fraction. So for graphing purposes, I need to make it a mixed number or a decimal. So if I divide this, 3 goes into 8 twice. So I get negative 2/3, or negative 2 2/3. So again, I'm going to just approximate this. So it's going to be almost to the negative 3. And then I would connect the dots. And that would be how you could graph using intercepts. So you find the 2 points, put them both on, one on the x-axis, one on the y-axis, and then connect the points. Good so far? We could have also rearranged the equation into slope-intercept form and done it that way also. Let's try another finding the intercepts. I'm going to show you a cool little trick. I call this little trick, I call it cover-up. So what I'm going to do here is essentially, remember, when you're plugging in zeros, anything times 0 is 0. So if I wanted to find my intercepts here, to find the y-intercept, I am going to cover up the x term. Now, this only works when it's in standard form. So to find the y-intercept, I cover up x, and I'm going to solve what remains. So I divide by negative 4, and y equals negative 7/4. Again, as an ordered pair, 0, negative 7/4. To find the x-intercept, I am going to cover up y and then solve what remains. Now, if this little cover-up trick confuses you, you just plug in the zeros. And the x-intercept will be 7/2. Let's try the next one. Next one again, same thing. I can do my cover-up trick. To find the y-intercept, I cover up x. I solve what remains. So I divide by 3. And my y-intercept is going to be negative 1. So 0, negative 1. For the x-intercept, I cover up y and solve what remains. Again, it only works when it's in standard form. So then you get negative 3 over 4, 0. And that is your x-intercept. And again, if you were to graph them, you would graph the first point, the 0, negative 1, along the y-axis, graph the negative 3/4, 0 on the x-axis, and connect the points. The next thing we're going to talk about is slope. So at the beginning, we already saw that slope is represented by a lowercase letter m. Again, remember, slope is defined as rise over run. And slope is also defined as the change in y over the change in x, or you might also see it as delta y divided by delta x. So there's two things that you can do for this type of problem. I highly recommend that you memorize that when you see a vertical line, you should automatically know that this has an undefined slope. So when it's vertical, it's undefined. But I'm going to do the math here to show you what happens. If I didn't memorize that this has an undefined slope, or let's say it wasn't even graphed for me and it was just order pairs, I could pull, first of all, 2 order pairs off my line. Doesn't matter where. So I'm going to actually write down the order pairs of where I just put the 2 points. So this is the order pair 2, 2. And this is the order pair 2, 1. I am going to use my slope formula. And I'm going to do, and this one's going to be my x2, y2. Doesn't matter which one. And this will be x1, y1. So I'm going to do 2 minus 1 divided by 2 minus 2. After you subtract, if you end up with a 0 in the denominator, this is an undefined situation, because remember yesterday when we were finding the domain and we were checking all those fractions to see where the denominator would be a 0? So when you get a 0 in the bottom of your fraction, the slope is undefined. I have all kinds of little tricks that maybe will help you remember, because I know everybody gets confused with this. So take the word undefined, for example. What I do is I take the first 3 letters of the word and I use it sort of like an acronym. And what I'm going to do for the U, so whenever I see UND, that tells me it's up and down. So when my line is graphed and it looks like an up and down line, I know my slope here is undefined. Okay, another trick that maybe it'll help you, maybe it won't, is think of the slope here. If it's got a number in the top and a 0 in the bottom, think of the number as being an N and an O. So number over 0 or NO, no slope, so it's undefined. Whatever's going to help you remember, when the 0's in the bottom, it's undefined. The next example we're going to do is where it's vertical. I don't want to see you leave the fraction like this. I want you to be able to, analyze this and tell me that it's undefined. Does that make sense? Yes.
Do we have to do the work during the test if we see or not?
No, that's fine. You can just write undefined or 0. Yes. The horizontal line, and when we do the slope formula, we're going to get a 0 in the top, and that's going to simplify to 0. So I'm going to again take the order pairs from the graph. It doesn't matter where you pull them. So I'm going to pull this one, and I get the order pair 1, 1. And I'll pull this one, And 1, 2, 3, 3, 1. I'll do the slope formula. Again, this could be my x2, y2. This could be x1, y1. It doesn't really matter. You still get the same slope. So here, I'll do 3 minus 1 over, no, I'm doing this backwards. That is my x. I need to do 1 minus 1 over 3 minus 1, and I get 0 over 2. When the 0 is in the numerator, this will simplify to 0. So when the line is horizontal, so a horizontal line or a 0 in the numerator, this has a 0 slope. I think of the word horizontal. Vertical doesn't have any O's in it, so you could also think of the word horizontal has some O's in it, which look like zeros. Whatever's going to help you. As far as the NO trick, that's the undefined. Here it could be, it's okay. Think of the K as a constant, it's a number, so that gives you a 0. Whatever's going to help you memorize. I highly recommend that you memorize when it's a horizontal line, the slope is 0, and when it's vertical, it's undefined. As you may be presented the question as a graph, or it may be presented to you as two ordered pairs. So just be able to recognize if you were to do the slope formula and the 0 ends up in the top, when it equals 0, or when it's in the bottom, it's undefined. Yes?
So on the test, we just write 0 slope?
Yes. So on the test, I don't want to see the answer written as 0 over 2. I want to see you simplify it to 0. And then on the question, okay, so now we're going to actually do a problem that doesn't give us a 0 or an undefined slope, which is actually going to give us a number. Now, again, it doesn't matter which one is labeled as x1, y1 and x2, y2. I'm going to label this as x2, y2 and this one as x1, y1. Now, let me show you if I do it, I'm going to do it both ways to show you I still get the same answer. So let's say instead I said this is 1s and these are the 2s. I'm going to still get the same slope. So for the first one, I'm going to do 8 minus negative 3 over negative 4 minus 2. Here, if I did this minus this and this minus this, I still get the same answer. So negative 3 minus 8, and then 2 minus negative 2. So notice here I get 8 plus 3, which is 11, and then the denominator is a negative 6. But here, the negative's on the top and the positive's on the bottom. Either way, remember, it doesn't matter where your negative sign is, whether it's out front, if it's on the top in the 11, or if it's in the bottom on the 6. All three of these mean the same thing. Now, if you do the slope formula and you have a negative in the top and the negative in the bottom, simplify it to a positive, because a negative divided by a negative is a positive. Let's try another example. So here I have the order pair 2, 7 and 2, negative 4. Again, I'll label this as x2, y2, x1, y1. Again, it doesn't matter. So 7 minus negative 4 divided by 2 minus 2. I get 11 over 0. Again, you should be able to tell me that this means this slope is undefined. When the 0 is in the denominator, it's undefined. So that's how to find the slope from two order pairs. Next, we're going to find the slope from equations. So my first one is in a form that makes finding the slope super easy. If you've recognized this, this is in slope-intercept form. Y equals mx plus b. when it's in this form and the equation has been solved for y, the slope is the number in front of x. So for this, all you had to do is look at it and tell me the slope was -4. Because again, remember, m represents slope and the b is the y-intercept. For the next one, it's in standard form. Now, someone in my other class said, well, can I plug in the zeros and find the intercepts? Yes, you can, but then you have to do the slope formula. So for this, what I would do is rearrange it into slope-intercept form and then just take the number in front of x. You can do this many different ways. So for me, the easiest way is to put it into y equals mx plus b form. So I would minus the 2x and get -3y is equal to -2x plus 5. Divide everything by -3. And I get y equals, notice it's negative over negative, so that's negative divided by a negative is a positive. And all I was looking for was the slope. So you would say the slope is 2/3. Same thing on this one. I'm just going to put it into y equals mx plus b form. So I'm going to divide everything by -2. And I get y, again, negative divided by a negative. It will make this become a positive slope. And my y-intercept is -7/2. So the slope is 3/2. So your homework is from pages 221 to 222. It's numbers 7 through 23 odd, 35 through 41, and then 53 through 57 odd.